Alright, hey everybody. We're dealing with our limits functions now, our limits. And this is that part where we are moving forward into our calculus portion of the class. So here, for those that are going into calculus next, you're going to be dealing with the limits and all the different portions of it. We're not going to go through everything. We're going to hit it. We're going to talk about some stuff and then move forward on there. So we're going to start off with, first off, what a limit looks like. So limits find the y value, L, as the function approaches a certain x value. So you're probably like, what? So in other words, first off, we have this, the limit function and what the function looks like. So the limit of f of x as x approaches a, so limit of a function, it represents L. That's your limit. That's your y value that you're trying to find. So the thought process behind limits is that as x approaches a number, as x gets, like as you are actually literally on the graph and you are following the graph itself, as x approaches a specific number, you will find a y value that number goes to. So it might not make a whole lot of sense, but as of right now, it's going to be a mindset change because you're trying to interpret a graph, trying to interpret numbers from a graph, values from a graph. So that's what we're going to end up doing. We're going to keep doing that. All right. So if you remember back when we did the worksheet where I had you guys substitute the value into the function and then work it out and get an answer, or you had a graph where we actually I gave you the graph and I gave you what the x value was and you had to find the y value from the graph. Or if I gave you the y value and you had to tell me what the x value was from the graph, limits pretty much deal with that. Because our first portion of limits that we're going to deal with is the graphing portion. And this is going to be our example one. Right. So I'm going to write this down. And this is a graph here, and this is the number 8. Number 8. And we're going to go back to the worksheet that we did earlier. We're not go back to it, but we're going to think back to it. And we're going to use that to help us figure out what's going on here. So it says, example 1, consider the graph of the function y equals f of x shown below. And find each pair of values. So for A, we're going to find f2. And then we're going to find the limit of f of x as x approaches 2. Not going to be bad out. All right, so for the first portion, f of 2, we said, okay, when this happens, we say when x equals 2, what is your y value? So when x equals 2 right here, our y value on the graph is 6. So 2, 6. So it means this is 6. Okay, now when it comes to this next portion, for the limit, let me change the colors here. The limit is actually going to take a look at what's happening around the actual, the x value of 2. So what's happening? What is this value going to? What is y going to as x approaches 2? So on your graph here, you know x equals 2 is right here. This portion right there. That's x equals 2. When it comes to our limits, what we have to figure out is what is happening as this side of the graph approaches x equals 2. As this graph moves closer and closer to x equals 2, we're trying to figure out what is our y going to? What value of it? Here. But as it approaches x equals 2, it's going down and down and down until it gets to 6 right there, right? So here this comes down, it goes to 6. Then also, let's take a look on the other side, because we have to check both sides here to make sure they match up. This side coming here, if we're going towards 2, x equals 2 right here, your y value ends up going towards 6 again. So y equals 6 here. So as x approaches 2 from this side, it goes to 6. As x approaches 2 from this side, it gets to 6, or goes to 6. So our answer is 6. So the value at x equals 2 is 6, but here, when it comes to the limit, it actually goes to 6 also. It approaches that same point. Now I'm showing you this because for the second portion, those two values are not going to be the same, because they will not always be the same depending on what the graph actually shows. So I'm going to show the next portion, so f of 4 and a limit of f of x as x approaches 4. This is where x equals 4, right? Okay, so that's where x equals 4. There's an open circle right here. Just to close off. It's an open circle right here. Remember, open circles mean that the function does not equal anything there. There's no value at that point. It's an open circle. It's like the graph goes, then at that point it stops. Then it picks back up on the other side. So there's nothing right there. But then when we talk about closed circles, that's where the value is. That's where something is. So at x equals 4, there's an open circle right here with no value at all. There's nothing there. But at this point, there is a closed circle. So for f of 4, change that over. For f of 4, the answer is just 6. Because again, when x equals 4, so our y value is 6. So when x equals 4, y is 6. Because there's an open circle there, so nothing's at that spot. Now, when it comes to our limits, limits focus on the graph itself, not necessarily the points. It focuses on the graph, what's happening on the graph. So when we do our limit here, x approaches 4. As we do our limit here, again, we're looking at our graph going this direction. So I'm going to pull this line back here, so we're focusing on this where our focus should be at x equals 4. So when we do this, again, the limit deals with the graph. So the limit focuses on the graph. So it focuses on the function, that line, whatever is happening. So when it comes to this function here, we're looking at this line, and as x gets closer and closer to 4, your y value is going towards something there too. Same thing on this side, as x is getting closer to 4, your y value is going towards 4. So we would say this is 4. So again, when you do f of a number, that means at that point, what is your value? But when it comes to the limit, you're looking at the actual graph itself and following the graph until you see what y value is that point approach. Is it getting closer and closer to? So here, again, as this graph comes down, it gets closer and closer to x equals 4. And because of the open circle, you know it never equals 4, but it gets closer to. The limit equals 4. Okay? So at this point, we're going to keep moving forward, and then we're going to go from there.